A Carnegie Institution for Science audio press release for July 8, 2014. Cosmic accounting reveals missing light crisis. Something is amiss in the universe. There appears to be an enormous deficit of ultraviolet light in the cosmic budget. The vast reaches of empty space between galaxies are bridged by tendrils of hydrogen and helium, which can be used as a precise light meter. In a recent study published in the astrophysical journal Letters, a team of scientists finds that the light from known populations of galaxies and quasars isn't nearly enough to explain observations of intergalactic hydrogen. The difference is a stunning 400%. Carnegie's Juna Kollmeier is lead author of the study. She says that it's as if you're in a big, brightly lit room, but you look around and see only a few 40-watt light bulbs. Where's all that light coming from? It's missing from our senses. Strangely, this mismatch only appears in the nearby, relatively well-studied cosmos. When telescopes focus on galaxies billions of light years away, and therefore are viewing the universe billions of years in its past, everything seems to add up. The fact that this accounting works in the early universe, but falls apart locally, has scientists puzzled. The light in question consists of highly energetic ultraviolet photons that are able to convert electrically neutral hydrogen atoms into electrically charged ions. The two known sources for such ionizing photons are quasars, which are powered by hot gas falling onto supermassive black holes over 1,000,000 times the mass of the Sun, and the hottest young stars. Observations indicate that the ionizing photons from young stars are almost always absorbed by gas in their host galaxy, so they never escape to affect intergalactic hydrogen. But the number of known quasars is far lower than needed to produce the required light. Kollmeier explains that either our accounting of the light from galaxies and quasars is very far off, or there's some other major source of ionizing photons that we've never recognized. Scientists are calling this missing light the photon underproduction crisis. But Kollmeier notes it's the astronomers who are in crisis. Somehow or other, the universe is getting along just fine. The mismatch emerged from comparing supercomputer simulations of intergalactic gas to the most recent analysis of observations from Hubble Space Telescope's Cosmic Origins spectrograph. Ben Oppenheimer, a co-author from the University of Colorado, says that the simulations fit the data beautifully in the early universe. They also fit the local data beautifully if scientists are allowed to assume that this extra light is really there. It's possible the simulations don't reflect reality, which by itself would be a surprise, because intergalactic hydrogen is the component of the universe that astronomers think they understand the best. Neil Katz, a co-author from the University of Massachusetts at Amherst, thinks that the most exciting possibility is that the missing photons are coming from some exotic new source, not galaxies or quasars at all. For example, the mysterious dark matter, which holds galaxies together but has never been seen directly, could itself decay and ultimately be responsible for this extra light. Katz says that you know it's a crisis when you start seriously talking about decaying dark matter. The great thing about a 400% discrepancy is that you know something is really wrong, according to co-author David Weinberg of The Ohio State University. Scientists still don't know for sure what it is, but at least one thing they thought they knew about the present-day universe isn't true. Whether the explanation is exotic or not, astronomers will be working hard to shed light on the mystery. With the independence for nimble pursuit, Carnegie scientists tackle some of the most profound challenges in modern science, fundamentally changing what's possible for us, our planet, and our universe.